Welcome to the ET335 how-to video for the Ouartus introduction. We're going to analyze signals. Okay, here we are at our Ouartus. We've already run the compilation here and we had it successful. And let's go ahead and do the waveform analysis. So let's go to File, New. And we're going to go grab a university program VWF, and we're going to get a simulation editor here, and we're going to go to Edit, Insert, Node or Bus, Node Finder. We're going to choose our OR gate G, and we're going to go to List, and we're going to do our double arrows here to move everything over. Okay, and then we populate our waveform here and click on A. Let's do clock, and that one's going to be good. Let's click on B and let's do clock, and we're going to change the count every 20 nanoseconds. Okay, and then we're going to go to simulation options. We're going to choose model sim, simulation, run functional simulation, and we're going to save it, and we're going to get an analyst window, and it should be all green and say complete, and then our waveform generator pops up, and we're going to do control spacebar until we get the whole thing. Here we have 0 and 1, 2, 3, and then reset back to 0. So there we have our complete chart. Okay, let's take a close look at our waveform here. So what I've done is I set the first A to 10 nanoseconds, and then I set the clock on B to 20 nanoseconds, and what I end up with is basically a binary input that we could cover all of our inputs for 2. So if we have 2 inputs, we're going to have 2 to the 2, and that's going to give us 4, which is going to go from 0 to 3. Okay. So that's what we have every possible input, and then we're going to look at our OR gate. So an OR gate, 0, 0 is going to be what? 0. 1, 0 on an OR gate will be 1. 0, 1 is going to be 1. 1, 1 is going to be 1. So we have simulated an OR gate. Okay, let's analyze our OR gate. So here we have our OR gate. So we have inputs A and B, and our LED is called for our output. So with an LED, either one of these is high or both are high, we're going to get a high out. So when we have a 0, 0 into an OR gate, it's going to be a 0. So we have a 1, 0, it's going to be a 1. 0, 1 is going to be a high, and 1, 1 is going to be a high. So it acts like an OR gate is what we want. Okay, we compiled successfully, so let's close out of our report. And now let's do a waveform analysis. So we're going to go File, New, and we're going to utilize our university program VWF, and we're going to go to Edit, Insert, Node or Bus, and we'll go to Node Finder, and actually we should be able to just go to List, and we have all our inputs, double arrow there. Okay, and now we have our chart start. So let's go ahead and click on A. Let's go to clock, and let's leave it at 10 nanoseconds. Next one, we're going to double that clock with 20. Okay, and the next one we're going to go to C, and we're going to go to double that. We're going to be 40. D, let's go to the clock and let's go to 80. Okay, so now let's go ahead and simulation. Options, we're going to stick with model sim. And simulation, we're going to run a functional. And so we're going to save it and wait a second or so. Here we come up with our information compiler, and we should pop up with a chart. So let's go ahead and control spacebar. And nope, we're going to have to go back, spacebar. And that looks good there. Okay, let's take a look at our and/or wave here. And we have 4 inputs, so we're going to get 2 to the 4th power equals 16, and we're going to go from 0 to 15. And we're going to go through and we're going to have a binary count. So let's just put 1s. Yeah, all the other ones are obviously 0s. Okay, and you remember that these have weights. This is a 0, these are 2, 4, and 8. Alright, so our first one's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, and then back to 0 again. Okay, let's take a look at our waveform for our and/or circuit. So our circuit is 2 AND gates feeding into an OR gate. And we have 4 inputs, A, B, C, D. So if A and B are high, then we're going to get high into our OR gate. It's going to get us high out. If C and D are high, we're going to get a high out of our OR gate. If everything is high, we're also going to get a high out. So let's take a look at here. Here's our output. We have a 1. A and B are 1. A and B are 1. A and B are 1, and C and D are 1, and C and D are 1, and we have C and D are 1, and at the very end we have A, B, C, and D are 1. So that's a good and/or circuit.